Hello and welcome. In this video, I am going to talk about page 20 of your Quarter 1 Algebra 1 notebook. This video covers more solving linear inequalities. So just as a recap, solving linear inequalities is really the same as solving linear equations, except for that last step when you're going to divide or multiply to isolate that variable. If you divide or multiply by a negative number, you must flip the sign. And actually, I said the last step. That's normally where it falls. Sometimes you might divide or multiply by a negative number somewhere in the middle. At any rate, number 6 here. It does look like I have to distribute, and if I do have to distribute, I should do that first. So I have 8 times 8x, that's 64x. 8 times 1 minus 8 is going to be greater than or equal to negative 8 plus 8x. Now, when I look here, I've got no like terms, but I do want my x's to be on the same side, so I will subtract 8x from both sides. 64x minus 8x is 56x minus 8 is greater than negative 8. Alrighty, now I need to isolate my variable. The first thing to do is to remove my constant. This is minus 8, so I will add 8 to both sides. And now I have 56x is greater than 0. And this is great division for me because 0 divided by anything is 0. The only thing I'd have to pay attention to here is, am I dividing that 0 by a negative number? This is positive. I'm going to be dividing both sides by a positive 56. So I do not have to flip the sign, and x is greater than 0. So anything greater than 0 is a solution to this linear inequality. In my next problem, I have a two-step equation. There's no distributing, no combining of like terms. I'm going to remove my constant first, minus 7, minus 7. I have negative 3/5 x is less than or equal to 28 minus 7, which is 21. Now, in this case, I have a fractional coefficient, and I know using the inverse property of multiplication that if I multiply any fraction by its reciprocal, it equals 1. So I'm going to multiply both sides by the reciprocal of negative 3/5. And as I say that, I'm realizing I'm multiplying both sides by a negative number. That means the sign is going to flip. This will cancel out to a 1x, so x is now alone. And I'm going to multiply my fraction, put a 1 under here. I'm going to cross simplify because I have a denominator of 3, which goes evenly into 21. 3 divided by 3 is 1. 21 divided by 3 is 7. Multiplying fractions, I multiply straight across. I have 7 times negative 5, which is negative 35. 1 times 1, and this, of course, equals negative 35. So the answer is x is greater than or equal to negative 35. Moving on are some special cases, and just like in the equation special cases, I can anticipate the following. Maybe you're going to just pause the video and think of it. If you pause the video and thought, no solution and infinite solutions, you are right. So let's see which one is which. This is a lot of fun, this equation, because it doesn't quite follow the order I want it to follow. First of all, I have an expression over, so I've got a fraction, a rational expression here. I've got a constant on this side, and I really can't, there's nothing to distribute. I can't combine my x's or like terms because I have this denominator, so I am going to remove constant first. I really want to get this side, so 2x plus 5 over 2 is alone, so I can then remove the denominator. So now I have 2x plus 5 divided by 2 is greater than or equal to x minus 1 minus 3 is minus 4. Now I can remove the denominator because this is alone. I'm going to multiply both sides by 2 because this is essentially division. Use that opposite operation. This is where I said we're not even close to the final step, but if this were a negative 2, I would be flipping the sign now. On this side, it's pretty straightforward. I've got 2x plus 5 and greater than or equal to. On the next side, you have to remember that you're multiplying all of the next side by 2. So I am going to put this expression in parentheses so that the 2 can be distributed to the x and the negative 4. So I have 2x minus 8. I'm now at a point where I don't have like terms, but I do have my x's on both sides. So I'm going to subtract 2x from both sides. And I realize that 2x minus x is 0, and 5 is brought down, is greater than or equal to 2x minus 2x. Again, that's 0, and negative 8 is brought down. Just thinking about basic numbers, I know that 5 is indeed greater than negative 8. So this is a true statement, and this means it is infinite solutions. So there are infinite solutions to this particular linear inequality. On the other side, what I have here is another linear inequality where I need to distribute first. This one is a little more straightforward. I'm going to distribute the 3. 3x plus 3 is less than 3x plus 3. Now, when I had equations, I would have said, ooh, this is an infinite solution situation, but it's not quite as simple with inequalities. I really have to go through the process here. No, just more distributing, no combining like terms, but I do need to move my 3x over. 3x minus 3x is 0, and I have a 3 brought down. Is less than 3x minus 3x is 0, and I have a 3. 3 is simply not less than 3. That is a false statement. This means that there are no solutions to this particular inequality. However, I do want to highlight that if this were a less than or equal to, this would be a true statement. And then I go to the infinite solutions, right? It'd be a true statement because less than or equal to would mean that 3 is equal to 3, and it would fit. Last thing we're going to do in this video is just take a look at a proof of a multi-step inequality. The big difference is that I'm going to use those properties of inequality, the axioms of inequality, rather than the properties of equality. So here I have is let x equal 2x and y minus 4 is greater than negative 18. So if I look at the difference from here to here, I see that in place of the y, I have substituted the 2x. So this is substitution, the substitution property of equality. Now, when I go from this step to this step, I notice I am adding 4 to both sides. So that is the property, the addition property of inequality. And oh my goodness, I can't spell right now. It's getting a little bit to the end of the word, inequality. So there is the addition property of inequality rather than that addition property of equality because I've got an inequality. When I look to see the difference here, I notice that I have a negative 4 and a positive 4 replaced with a 0. So that is a number and its opposite equaling 0. That is the inverse property of addition. Oh, goodness, that was my dog. Scared me. Woo! Excuse me, Pippi. Shh. Now, when I look at the difference here, I notice that I no longer have the plus 0 because any number plus 0 is itself. So this is the identity property of addition. Let's move on, and it looks like I'm multiplying both sides by a positive 1/2. So this is the multiplication property of inequality. So again, big difference here is that rather than a property of equality, I'm just using a property of inequality. Now the pattern continues. When I multiply a number by its reciprocal, 2 over 1 times 1/2, and I result in 1 right here. That is the inverse property of multiplication now. So a number multiplied by its reciprocal is the inverse property of multiplication. And finally, any number times 1 is itself, and there is the identity property of multiplication. That's it for this video. Thanks so much, and see you next time.